So completing the square today, quadratic formula and discriminant, the end of the week. The chapter 8 work, so 8.4 through 8.6, if you have any of that, Friday is going to be it. And then we'll move on because we will have the chapter 9 quiz on Monday next week, Tuesday, if you're in hour 2, which none of you are. Eight-week progress reports will also go out the end of this week. So, important to get work done if you want it included in your 8-week progress report. All right, so on page 19 in your packet, today, completing the square and solving quadratic equations by completing the square. I will say of all the methods for solving quadratic equations, the square root method and completing the square method are probably the least used. And one of the reasons is the thing we're going to talk about on Thursday, the quadratic formula, is probably the most used method. And that's okay. These other methods do give us some nice formulas to work with, or equations to work with. So always keep them in mind, and they do have definite applications for later courses. All right, so we have x, what value c makes x squared plus 6x plus c a perfect square? So all right. So I am actually, now let's go like this. All right. So, excuse me. X squared plus 6x plus c, and we want to make a perfect square trinomial. So it says arrange the tiles to form a square. So I am going to do this down here. So this x squared square that we have is x units by x units. The x bars that I'm adding are x units by 1 unit. And so I put 3 of them underneath the x squared. I'm putting the other 3 on the other side of the x squared. And then to make it a perfect square, I am going to add these unit tiles. So they're 1 by 1. And I have to see how many of them I need to add. So let's see, there's 2. And I'm adding enough to make this a square. That's why it's called completing the square. So whoever named this method did a pretty good job. Let's see if I can. Oops. All right, so it looks like I needed 9 single tiles to make my square. So that would mean I added 9 to make a perfect square binomial. All right. So that's going to be important to remember, or that's going to hopefully help us to see what's going on here. So a method to solve quadratic equations by rewriting it as a sum or difference of a perfect square. Completing the square is useful when a quadratic expression is not factorable and when a equals 1. It can be used when a is not 1. We just need to do a little bit of more work there then. All right, so on page 20 in your packet, to make x squared plus b into a perfect square, we add b divided by 2, that whole quantity squared. And so if we add that to both sides, we would have x squared plus bx plus b divided by 2, the quantity squared. And that would be our completed square, or our perfect square trinomial. And the factored form would be x plus b divided by 2 the quantity squared. All right, so find the value of C that makes the expression a perfect square, then write the expression as the square of a binomial. In other words, we're going to write the expression, find the value of C, and then write that expression. All right, so in this case, our value of B is 10. So we need to take 10 divided by 2. And I think 10 divided by 2 is 5. So C, in this case, what's labeled as C, is going to be 10 divided by 2 squared, or 5 squared. And that would be 25. And to write it as the square of a binomial, that's the factored form. X plus 5 squared. So for letter B, C equals negative 24 divided by 2 squared. And notice the parentheses. The parentheses are important. Negative 24 divided by 2 is negative 12. And negative 12 squared is positive 144. So the big thing, this value for C is always going to be positive. That's the only way we could have a perfect square, or the square of a binomial. And so the factored form, the square of the binomial, in this case, it's going to be x minus 12, the quantity squared. So it's always going to be whatever this value is, and I should have left this one in parentheses, before we square it, is going to be in our factored form. All right, oops. Try a couple more here. X squared minus 8x plus C. So C is going to be negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4. And we're going to square negative 4 to get 16. And the great thing is, once we do that, we already know what this is going to look like in factored form. X minus 4 squared. All right, now the fun one. C is going to be 7 divided by 2 squared. Again, I would not write this as a decimal. I would leave it as a fraction. So there's nothing we can do to reduce it. It's already as reduced as it will get. So when we square it, we square the 7 and we square the 2. The factored form, x plus 7/2 squared. Let's make that 7 a little bit better. And that would be our expression. All right, so try now. This is on the bottom of page 20, but go ahead and figure out the value of C that will make the expression a perfect square, and write the expression as a perfect square binomial. All right, so for that problem, or for these two problems, we would find that C is 121, and that would factor into X X plus 11, the quantity squared. For the second one here, (81/4) and X minus 9/2, the quantity squared. All right. So to use this method for solving an equation, we want to get the left side in the form x squared plus bx. So, and we want the x squared to be positive. There are ways you can do that. If it was negative on this, we could add it to both sides and make it positive. We'd be okay. To complete the square, add b divided by 2 squared to both sides of the equation. Factor the left side of the equation into the square of a binomial, and we already know what it's going to look like. It's going to be x plus b over 2 squared. Undo the squared by taking the square root of both sides of the equation. Don't forget the plus or minus. The plus and minus. Get the x by itself and write your final answer. So if we just keep those steps in mind, step 1, get the left side, so it's x squared plus bx. So all of the terms with x's are on the left-hand side. For that to happen, we would need to add 8 to both sides of our equation. So completing the square, I would take my b divided by 2 and square it. That would be 3 squared. So I add 9 to both sides. Equals 9. So I'm going to add 9 to the left side of my equation, making so that that can be a perfect square. And I'm going to add 9 to the right-hand side. And I have to add it to both to keep it equal. Factor the left-hand side. So that is going to be x plus 3 squared. And I can add the 8 and the 9 to get 17. Undo the squaring by taking the square root of both sides. On the left-hand side, the square root of something squared is just that thing that's being squared. So I get x plus 3. On the right-hand side, I get plus or minus 17. Get the x by itself. So I'm going to subtract 3. From both sides of my equation. Be careful when you do this. So I get negative 3 plus or minus the square root of 17. And we could check to see if the square root of 17 reduces, and we should check. But in this case, 17 is a prime number, so it will not reduce. So I have 2 solutions. It doesn't look like it, but this is the way I would write my solution. My solutions are x equals negative 3 plus the square root of 17, and x equals negative 3 minus the square root of 17. All right. What are the solutions of each quadratic equation solved by completing the square? All right, so first thing we need to do, get that plus 16 to the other side of the equal sign by subtracting 16. All right. Now I'm going to figure out what my value for C is going to have to be by taking negative 14 divided by 2 and squaring it. Negative 14 divided by 2 is negative 7, and negative 7 squared is positive 49. So I have x squared minus 14x plus 49 equals negative 16 plus 49. Factoring the left-hand side, and again, we already know it's going to factor into x minus 7 squared. Negative 16 plus 49 is 33. Again, you could double check that if you wanted. Now we're going to take the square root. On the left-hand side, we're just left with x minus 7. On the right-hand side, we get plus or minus 33. And you could check to see, does 33 break down? It's not even, so 2 will not divide into it, but 3 will. 3 goes into 33 11 times. 11 is a prime number, so we don't have any pairs of factors that we can take out of the square root. So that square root 33 is going to be part of our answer. Add 7 to both sides, 7 plus or minus the square root of 33. Always a good idea to check to see if things reduce or not. All right. Let's take a look at this next example. X squared plus 10x plus 1. So again, we want to get the x squared by itself. So subtract 1 from both sides. I misspoke there. We want to get the x's on one side by themselves, not the x squared. Find our value for c. It's going to be 10 divided by 2. So the coefficient, the number in front of the x, divided by 2 squared. 10 divided by 2 is 5. So we have 5 squared. And that would be 25. So we add 25 to both sides. The left-hand side factors, x plus 5 squared, again, that 5. It's right there. Negative 1 plus 25 is 24. Take the square root. So on the left-hand side, the square goes away. On the right-hand side, I want to break down, see if 24 can be broken down. 2 and 12, 2 and 6, 2 and 3. So there's a factor of 2 out front, and inside, we would take 2 times 3. I'm going to actually multiply 2 times 3 in my head and get 6. So plus or minus 2 root 6. Subtract 5 from both sides. Now the 5 and the 2 we cannot combine because the 2 has that root 6 with it. So that would be our final answer. All right, so go ahead and try this one. I'll give you a few minutes to work on it, and then we'll move to the next set. All right, let's take a look. So again, I will go through each step. I'm not going to write it all out like I did for the examples, but you should have added 4 to both sides. I think this is actually one, the x squared plus 6x is one that we did already. So add 9. take the square root. X plus 3 equals plus or minus square root 13. Square root 13 is prime. It's not going to have any perfect square factors that can be removed. Subtract 3. X equals negative 3 plus or minus root 13. All right. So the equations, when we're completing the square, are not always going to be given to us in our standard form. We may have to manipulate them a little bit. So in this case, we want to get the x terms all together on one side and the terms without x on the other. So I would subtract 14x from both sides. And then subtract 9. All right. So if I then find my value for C, C is going to be negative 14 divided by 2 squared. Negative 14 divided by 2 is negative 7. And negative 7 squared is positive 49. So we're going to add 49 to both sides. Negative 9 plus 49 is 40. Factor the left-hand side. X minus 7 squared equals 40. Take the square root. So x minus 7 would equal plus or minus the square root of 40, which we should check. Can it be reduced? Can we take out a perfect square factor? 40 is even, so we can take out, or we can break it down into 2 times 20. 20 is even, so that's 2 times 10. 10 is even, that's 2 times 5. So we do have a perfect square factor and a couple of non-perfect square factors. So we can take out a factor of 2, and underneath we have 2 times 5, which is 10. And we want to add 7 to both sides. And there's our answer. All right, going with another one that's a little bit crazy. Here we're going to, we have x squared equals 59 minus 6x. So we want to get that 6 minus 6x moved over to the left-hand side of the equation. We can do that by adding 6x. Finding our value for C, we would take then 6 divided by 2 and square it. 6 divided by 2 is 3. 3 squared is 9, so we're going to add 9 to both sides. The left-hand side factors, x plus 3 squared. Again, that plus 3 comes from there. 59 plus 9 is 68. Take the square root of both sides. So on the left-hand side, we're left with x plus 3. On the right-hand side, we should see if 68 has can be broken down. Two and 34, 2 and 17. So we do have a factor of 2 that can come out. And 17 is prime, so it's not going to have any factors. So we're going to have 2 outside, square root of times the square root of 17. Subtract 3 from both sides of the equation. And you have your answer. All right, one for you to try. All right, so this one is already in that the x's are all on the left-hand side and it's equal to a number, so we can look to figure out our value for C. And that's going to be negative 10 divided by 2 squared. Negative 10 divided by 2 is negative 5. Squaring 5, we get 25. So we're going to add 25 to both sides of the equation. Factor. Again, this one's minus 5 because that's what our value was that we squared. Another way to think about it, if this is subtraction, if we're subtracting the x term, we're going to have subtraction in our factored term for completing the square. Negative 18 plus 25 is positive 7. Take the square root of both sides. So we get x minus 5 plus or minus square root 7. And we can double check that 7 does not have any perfect square factors other than 1. It's not even, so 2 will not factor into it. It's not evenly divisible by 3. It's not evenly divisible by 4. It's not evenly divisible by 5. And it's not evenly divisible by 6. So 7 is not going to reduce. It's a prime number. Last step then, get the x by itself by adding 5. And you'll notice I always write the square root at the end for a couple of reasons. First of all, then I'm not confusing if that 5 is underneath the square root or not. It's not, but it's out in front, which helps. And it's kind of the way that I was taught to do it. So you will see it that way. I think that's the common way to write a number plus or minus a square root. You see it just like that.